Hey guys, we are Group 25, which consists of me, Howard, and my two lovely teammates, Thanh and Sundos. We will talk about the chemistry of greenhouse gases and how they impact us and our planet. The sun's radiations travel towards Earth through space in the form of infrared radiation. Less than half of the radiation is reflected by the atmosphere or absorbed by the clouds in the sky. Most of it reaches the Earth, where it is absorbed by the land and oceans, providing warmth to the life on the Earth's surface. Some of the heat radiation is then released back to the atmosphere, where part of it escapes back towards space. Most of it is captured and retained thanks to the work of greenhouse gases, which helps maintain the warmth for life on planet, essential for survival. However, excess greenhouse gases could decrease the amount of heat radiation released back towards space, and instead increases the amount of absorbed and reflected heat radiation back into Earth. This is a problem, as the increase in heat trapped will gradually increase the Earth's temperature. So what are the 5 types of greenhouse gases?
Now let's move on to detail about common greenhouse gases, in which carbon dioxide is the most abundant. It is responsible for 65%. Carbon dioxide, emission of carbon dioxide come from wildfires, volcanoes, respiration. Volcano and wildfire are the most significant natural source. Carbon dioxide has a linear structure. It is a colorless, odorless gas soluble in water to form carbonic acid. It is not reactive at room temperature, but reactive in high temperature. Now move on another greenhouse gas. Methane can be formed as a byproduct of ruminant digestion, a product of rice farming, burning biogas. Methane has the heterogeometry. It is a colorless, odorless gas lighter than air, rarely soluble in water, can dissolve in organic solvent. It's stable but reactive in reacting with oxygen and hydrogen. Emissions of naturals come from natural sources and human sources. In the human sources, agriculture is given mostly. For natural sources, it's solid under natural vegetation. Microbe breaks down nitrogen to form natural oxide. Natural oxide has a linear geometry. This is a colorless, slightly squeezed touching gas. It's now a laughing gas, very soluble in water but soluble in organic solvents. It's an oxidizing agent, so can undergo combustion reaction. Ozone resides in atmosphere with two levels, troposphere and troposphere. In the troposphere, ozone is formed from photochemical reaction of nitrogen oxide and volatile organic compound under sunlight. That's why the sources of ozone are soil transport and oil production. Ozone has band geometry. Ozone is blue gas, iris melt. It is strong oxidizer, high reactivity, so it can react with salt of iron 2 and alkane. Refrigerator and air conditioner are the most common emission of CFCs. Also, aerosol cans are manufactured using CFCs. Although we were eliminated, but it still affects the ozone layer. CFC is made from carbon, chloride, and fluoride. They have three main compounds. CFC are non-flammable, odorless, and tasteless. It has volatility and boiling point is nearly zero. That's why it's a UA refrigerant gases. CFC are stable and not reactive, but under UV radiation, it will be converted into chloride atom, will react with ozone to form oxygen.
CFC is a unique type of greenhouse gas. Unlike the other gases, which basically traps infrared radiation through molecular vibrations, CFC depletes the ozone layer through radical reaction, allowing more infrared radiation to enter the atmosphere. So how does this radical reaction work? Firstly, the UV in the atmosphere will break one carbon Cl bond, forming a chloride radical. These chloride radicals will then react with ozone to produce a chloride oxide radical and oxygen. A pair of chloride oxide radical can then react with each other to form chlorine peroxide. Chlorine peroxide is unstable and may undergo an initiation reaction by UV light to cleave either side of the ClO bonds to produce a maximum of 2 chloride radicals, which may then react again with other ozone molecules shown in step number 2, thus repeating the cycle once more.
After learning the nature of these gases and where they're emitted from both naturally and artificially, we can move on to discuss what occurs to planet Earth when a high abundance of these gases are emitted into our atmosphere. We are expecting to see numerous unfortunate events if the climate crisis progresses rapidly, such as rising maximum temperatures, rising sea levels, higher ocean temperatures, and even an increase in rain. We are running out of time. Therefore, it's important to see how these chemicals harm our human life and planet. An increase in CO2 makes our ocean more acidic, which brings up the topic of ocean acidification. This disrupts the ocean cascade and harms marine life. Later, the CO2 goes back into our carbon cycle and into the ozone layer. Additionally, this causes an increase in sea level, which places human life in danger. The crisis is connected with respiratory issues and results in infant mortality. This is our strategy. Step 1, get energy to be green. Step 2, decarbonize. Step 3, divestment. Step 4, coalition building. And step 5, save planet Earth. The figure above depicts a cycle that has yet to be extensively broken. It starts with large corporations emitting high amounts of carbon dioxide into the atmosphere, where it enters the carbon cycle, into the ocean and is stored there for marine life. Unfortunately, this excess amount of CO2 leads to the topic of ocean acidification and an increase in sea level. Ultimately, institutions' objectives do not align with green-motivated projects. Therefore, the cycle remains continuous. Now, what can we do to help join the climate crisis and aid it? We, as residents in Southern California, can aid the crisis by trying our best to convert energy to be green. Our own school, UCSD, has a Green New Deal organization that has 4 core goals and campaigns: to decarbonize by 2025, to educate individuals, divestment, and coalition building. This is a step to aid the issue behind the immense emission of greenhouse gases. Current research discusses the UC climate action plans and the California state plans, since we want to look at the emission reduction goals of both UC and California. The main focus is energy. We want energy to go green. Some examples of green energy include hydropower, wind power, biofuel, and solar panels. Thank you so much for listening, and I hope you enjoyed this discussion about climate change and the drastic events and how we need to implement change as soon as possible.